What happens when a machine plays chess not like a grandmaster, but like a machine that sees too far ahead? Not like a brute force calculator that blunders into complexity. Not like a human with instincts. It plays like a system that measures one move against thousands of futures and keeps the one with the highest expected reward. People hear the headline and assume the story is straightforward. AI beats chess. Then stop at the trophy moment. The real story is the move that comes after that. The one that feels wrong. The one where a commentary panel pauses, rewinds, and asks, is this legal? No. Is it ugly? Yes. Is it losing? Maybe. Is it actually best? In classic chess terms, humans judge first by appearance. Good chess looks balanced. A move should claim territory, increase mobility, and protect king's safety. A machine can ignore familiar patterns if the long line says the position is still winning. To understand how this happens, we have to separate three parts. This is where many explainers simplify too far. First, chess itself. Every position has millions of possible continuations. That is the reason humans learn openings and patterns. They need cognitive shortcuts. Second, search. A chess engine chooses a move by looking ahead, branching at possible replies, then pruning weak ones. Think of it as a branching telescope in reverse. You focus on the branches most likely to beat your opponent. Third, the evaluator. This is where modern systems differ from older engines. AlphaZero style systems build a model of position quality itself, then use that model to guide the search. They do not just brute force everything equally. They focus resources where value is likely to change the game. This is why a move can look irrational at first glance. The surface logic is not where the engine is optimizing. It is not optimizing for what feels intuitive in this move. It is optimizing the probability of winning much farther down the line. Now think about the phrase, beat every human. It is shorthand for a match context where an engine outperforms all known human players in a specific setting. It does not mean absolute game truth for every board. It means current humans, within current rules, with current time constraints, current move limits, and current hardware. DeepMind's architecture made a headline because it did not rely on large opening books or curated human game logs for its core skill. Instead, it learned from self-play. It played itself millions of games, millions of times, and each game rewrote its own beliefs about value. The common misread is it has memorized everything. It has memorized patterns, yes, but not in the same way a human memorizes a famous position and repeats it. It has learned a numeric map of what leads to advantage. When people say AlphaZero made no human move, they are usually talking about moves that are rare in human databases. That distinction matters. A move can be rare because it is difficult for humans to spot the compensation. Rare is not impossible. Rare means underused. Picture this moment in the film as a single board freeze. The engine chooses a pawn thrust that seems careless. Commentators have seen similar lines for decades. They still called it wrong because their evaluation function in this instant was shallow. The machine had a second line with quiet pressure and a zugzwang-like squeeze. Humans saw a sacrifice. The engine saw tempo and piece placement 3 moves later. This is where the tension comes from. Our brains are built to reject what does not match known heuristics. Machines are built to maximize expected return over a horizon we do not naturally hold. Let's be precise. It is still not thinking like us. It does not experience fear, ambition, or style pressure. It does not choose the move because it wants beauty. It chooses it because the network and search estimate are strongest against the next branching tree. That estimate can still be flawed. Engines can be confidently wrong in unusual tactical traps. But when they dominate at scale, the number of those wrong moves relative to strong lines is lower than top human play in those test settings. What changed with the modern era is less dramatic. It is cumulative. Better model architectures, better training pipelines, better pruning, better in-game tables, better tuning. The result feels magical only because we still see one move at a time on a board designed for human cognition. If we watch this as a pure technical system, we would say, It built a compact objective function for chess outcomes and optimized that function with search. If we watched it as a story, we would say, it saw a door and walked through it before we noticed the frame was there. There is a second twist. The most interesting chess moves made by engines today are not always deepest tactical kills. Some are strategic sacrifices, some are quiet repositioning, some are in-game compressions. Human teams label them strange because chess culture values narrative moves, not probability edges. And this is where the debate gets serious. Can a machine be creative? It can generate novel sequences that were not taught explicitly. Can a machine understand the game? It understands structure in the only way a machine can, through state transitions, value gradients, and prediction of response quality. The danger is not that machines are too creative. The danger is that we confuse unfamiliarity with error and confidence with wisdom. We assume if a move is ugly, it must be bad. In chess, ugly can be surgical. In board sports, humans and machines can both make mistakes. The difference is that humans feel regret and then remember it. Engines do not remember regret. They keep searching and adjusting. Now we can explain the headline move. We do not need the exact board line to make this clear. We just need this logic. When the machine sacrifices value in the short run, it can reclaim long-term structure that human heuristics undervalue. That is the hidden sentence the headline hides from the audience. It did not play a random genius move. It played a disciplined move with high expected value carry into tomorrow. At the table, this looks like arrogance. In engineering terms, it is a weighted future estimate. As AI chess gets stronger, the bar shifts. We will not debate whether machines can beat humans anymore. We will debate whether humans can tell apart strength, safety, and trust. The final question is the one that makes this video relevant outside chess, not just to chess players. If a machine sees a better line than you can explain, do you follow it because it was right? Or do you follow it because it is statistically hard to refute? That is the same question that decides how people use machine outputs in medicine, trading, education, and war games. For chess, we call that move weird, then brilliant if it works. For the wider world, we need to decide what works should mean before we surrender every future decision to a stronger estimator. The machine does not think like us. It computes like us and beyond us in one thing, and less like us in everything else. And that is why a move no human would make can still be a legal, winning, and unforgettable move.